Saxon's Calculus Lesson 30 is about the hyperbola, which you should have gotten very well in trig class, but they want to review it here. So their definition, the box at the start of Lesson 30 says, a hyperbola is the locus of all the points, the equidistance then of all the points at a coordinate x, y in a plane such that the absolute value, so no negatives, of the difference of the distance to two fixed points, which are called the foci, is a constant. So your hyperbola is two curves that are mirror imaging each other, and they're saying that wherever the focus points are and the distance that you would talk about between them, that's going to be the same number. Now, the formula for it is x squared minus y squared. So one of them will be a minus, either the x squared or the y squared. There will be numbers underneath that had been squared, and it equals 1. So it's just like the ellipse, except it has the minus sign. And then if the center is skewed, then you will have numbers up here attached with the x and the y. Okay, so I missed example 1. Using the definition for a hyperbola, write the equation for the hyperbola. So they wanted you to get to this yourself, but whose foci are negative 5, 0. Let's just write positive and negative 5, 0. And then the difference of the distance to the foci is 6. Oh, they wanted me to get to proving this formula by going through the fact that if I have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, the negative way, knowing then that the foci points are in the opening of a parabola, the parabolas would be doing something like that. And so wherever they might be, you can then say this actual dot to a spot on this parabola will connect to this other foci point, and we'll call this one xy, and we'll do the distance formula between, and this one was 5, 0, and this one was negative 5, 0. So we're going to go through the distance formula to find and then manipulate the distance formula, and that's how they get over to this piece. Now, you can go all the way through that if you so desire, but at this point, I feel like if you know where it's coming from and where its end result is, you could do that math work yourself. Now, since the remainder of example 1 was to get to here, what did they say here at the bottom, though? Axis foci lie on... Oh, we're not going to worry about that. Okay. Yes, this is where the center is at the origin. And if I as I said, if I flip-flopped it, this one had the negative was with the y squared when I'm graphing it this way. And if the negative is with the x squared, they're going to be graphing up and down. Now, example 2, graph 4x squared minus 9y squared minus 36 equals 0. Definitely not the right format. I'm honestly not sure what I was just saying. A bug was attacking me. So anyway, this was our formula in example 2. It was, oh, that's it. It was not in the right format. We need it to equal 1. So we're going to have to move the 36 over and then divide everything by 36 to turn it into the 1. So we have x squared over, and 4 dividing by 36 is 9. Minus the y squared. 9 dividing by 36 is 4, and the whole problem equals 1. Now we're in the right format to actually graph it. So on the x line, we're going to be doing square root of 9 is 3, both directions. Square root of 4 is 2 on the y line, both directions. And now, instead of actually being able to draw my shape immediately, I have to draw a box using those as my boundaries. And then through the 0, 0 and the corners of the box, I draw some asymptote or boundary lines. And usually they're dashes when you're talking asymptotes, but it's just easier to do this as solid. And then technically after you get it graphed, you're supposed to like erase all of this stuff because it's not actually there. But we always leave it there with that understanding. So if the negative is with the y squared, I am not graphing on the y-axis as a start. I'm graphing on the x-axis for the start. So these become my vertex points. And then I just use the boundary to graph the two parabolas making that hyperbola. And all I want to do is graph, so we're done with that one. Example 3. Sketch the graph of, there's probably not enough space. Of 9x squared minus 4y squared plus 18x minus 16y. They give me minus 43 equals 0. I'm just going to make it equal 43 by moving that 43 over. Now this time it says sketch the graph and then write the equation for the asymptote. So the equation of the lines that I'm creating through the boxes. So we need to complete the square to make these work. So we have 9 pulled out of x squared, and then out of 18 is 2x, minus 4 is pulled out from the y squared. And then if I'm pulling a minus 4 out, I'm adjusting the sign on this one as well. So that becomes positive 4y equal to 43. No change to that. So then the formats go to the squareds. And I follow completing the square. So half of this is 1. Squares to 1. 1 times 9 is 9. Add to the other side. Half of 4 is 2. 2 squared is 4. 4 times 4 is the 16. And adding to the other side. But it was negative, of course, because of the 4. So 43 minus 16 plus 9. 36. It's harder for me to do in my head for some reason. Now, every part is going to divide by 36, so we get x plus 1 squared. And then 9 over the 36 reduces to 4 minus y plus 2 squared. 4 dividing by the 36 goes to the 9, and it equals 1. We have the correct formula. Now let's graph it. So on the x-axis, square root of 4 is 2. On the y-axis, square root of 9 is 3. Drawing the box, drawing the asymptote lines. Because the negative is with the y, I again will not start here. I will start here and here. Drawing using the boundary asymptotes. That's the graph. Sketch the hyperbola and now write the equations for, okay, so the equations for these lines. We know that that should be y equals mx plus b. It crosses the y-axis at 0, so I don't have a b. My slope is 3 and 2, rise and run, so 3 over 2 is the m. And this way it's positive and this way it's negative. So I might as well just say y equals positive and negatives, 3/2 x. And just a second. Oh my goodness gracious. I was like, wait, something's wrong. I started at 0, 0. I can't start at 0, 0. I have to start at -1, -2. Oops. This is the start of the box. Then when I go to this direction and to this direction, 1, 2, 3, this direction, 1, 2, 3, this direction, my box is here. Oh, a little crookedy. Asymptote clarification lines. Vertex points are here and here. So obviously, all right, now the graph is fixed. And I do have a b, but my counting of up 3 over 2 is still correct. But I have to stop, and let's do the positive one first, 3/2 x plus b. So for the positive one, I need to use the corner of the box and its xy value plugged in here to solve for the b. So that's 1 over 1 up. And then b would be 1 minus 3/2, so it'd be like 2/2. 2/2 minus 3 at -1/2. b is -1/2. Yes. So my first one, I can't use the shortcut version. Y equals 3/2 x minus 1/2 for that b. Then for the negative version, -3/2 times the x plus a b. I'm going to use the bottom of the box here for this line. So that's 1, 2, 3, 4, 5, -5, 1 and -5. So then that's -3/2 adding, that's -10/2 plus 3/2. And that was -10. 10, 9, 8, -7/2, ha ha ha. Y equals -3/2 x minus the 7/2 that I solved for the b. Yes, and that then is the asymptotes for that one. And that was the last thing they asked me to do in lesson 30.